Welcome back everyone. We're going to be solving LeetCode 515, find largest value in each tree row. So we're given the root of a binary tree. We need to return an array of the largest value in each row of the tree, 0 indexed. So if we take a look at example 1, we're given this tree and we can see the largest value in each row is going to be 1, the root, 3 on level 2, and 9 on the third level. And we can see that here, our output is indeed 1, 3, and 9. So, how can we go about solving this, right? Well, they tell us we need to find the largest value in each tree row. So, knowing that, this is something we should run or utilize breadth first search to solve, right? Breadth first search will traverse a tree level by level. So, let's get that set up. We'll say, from collections, we will import our DQ, and we will set our queue up with the root node of the tree. And we are going to have an output array, so we'll say res is going to be equal to an output array. Now all we have to do is run breadth first search, right? So we'll say, while the length of the queue is not equal to 0. Now, this is where normally we would say, all right, well, we have a level, and then we're going to loop through all of the items in our queue, pop them off, and do some stuff, right? But instead of having this level here, right, we don't care about that. We're not appending a level, every level, onto our resulting array. We could do that and then find the maximum of each level and then return that, but that's going to give us a worse space complexity than if we were to just keep track of the maximum right here. So we'll say value is going to be equal to the float of, and we want to find the largest value, so we'll set it initially to -infinity. Loop through for I in range length of our queue, right? All the nodes in our queue. We're going to grab the node with queue.popLeft. Now we're going to check if the node is not none. If that is true, then we are going to check the value. If the node value is greater than the value, we're just going to set the value's new value equal to the node value. So we'll say if node.val is greater than the current value, we will set value equal to node.val. And then we can traverse the children and add them to the queue like we normally would. So we'll say if node.write is not none, we will say queue.append node.write. Do the same for the left side. Queue.append node.left. Now, once we break out of this for loop, we've traversed an entire level. So we should have found a maximum at that level. So what can we do? We can take this value and place it in our resulting array. So we'll just say res.append the value, and then at the end of this while loop, we can return the resulting output. So let's run this. Perfect, we passed both test cases, so we'll submit. Negative INF is not valid value. Okay, so we need to check in the case of an empty tree. So in the case of an empty tree, so if not root, we can just return an empty array. All right, that should work. So we'll run it. Should pass both test cases still. Yep, and submit. And we do pass. Perfect. So, time and space complexity of this. Space complexity is going to be O of n, and the time complexity is going to be O of n as well. All right, that'll do it for LeetCode 515.